we conducted sequencing of serial samples from this patient. And what we were able to demonstrate, looking at a pre-treatment sample here, a sample that was obtained 28 days after the start of drug treatment, and then a sample that was obtained a couple months after that, and finally a sample that was obtained at the time of relapse 6 months later. So what we'll notice is that IDH2 SF3B1 ancestral non-FLT3 driven clone was clearly selected for during the course of drug treatment, suggesting that yes, indeed, this is drug selection for a non-FLT3 driven cell population on a drug treatment. And conversely, you can see that we start off with the very large FLT3 mutant IDH2 SF3B1 drug-sensitive population that also slowly goes away on drug treatment. And then finally, most excitingly, we see that actually the relapse clone, the second relapse clone that is driven by NRAS and has the FLT3 NRAS IDH2 SF3B1 genotype, actually can be detected quite early on the time of drug treatment. So even after only 28 days on drug, we can already detect a small population, 0.1% of cells, that actually has this drug-resistant NRAS mutation. And this is clearly selected for on a drug treatment. After about 4 months on treatment, you can see that there is about 1.3% of the cellular population that's represented by this NRAS mutant clone. And then finally, the relapse clone at the time of frank relapse represents about 26% of the cellular population. And what this slide shows you is how nicely the clonal architecture is represented by the single cell sequencing compared to what you cannot resolve based on just looking at bulk sequencing alone. So what this represents is the variant allele frequencies that would have been obtained from just bulk sequencing of this population. And you can see two very clear things. One is that you cannot resolve that there is a cellular population that is clearly not FLT3 dependent, this SF3B1 IDH2 population, which basically is represented by stable variant allele frequencies throughout the course of treatment. But when you look at the single cell sequencing, you can see clear selection for this relapse clone that is non-FLT3 driven. And the second thing, and very important, I think, for use in a clinical scenario, is that the NRAS mutation cannot be detected until the time of frank relapse when you look only at the bulk sequencing. However, when you look at the single cell sequencing, you can clearly detect very early on treatment the emergence of a drug resistance NRAS mutant clone. So potentially this has great power when you think about the fact that in a clinical scenario, if you knew this, you may want to add another treatment or even switch treatment to avoid this relapse scenario. And this is shown very nicely here in this fish plot where we actually see evolution of the cellular populations during the course of drug treatment over time. So as you can see here, we start out with a very large IDH2 FLT3 SF3B1 drug-sensitive population that goes away on drug treatment. There's a smaller population of cells that probably represents the ancestral clone that is non-FLT3 driven, that's also clearly selected for on the course of drug treatment. And then finally, here is a secondary drug-resistant population with an NRAS mutation that is not, that you cannot see pre-treatment, but 28 days, only 28 days after starting drug treatment, you can already see emerge, and it's clearly selected for on the course of drug treatment.